Hey guys, today I'm going to show you another experiment with the chemical composition of water. Why I say chemical, I'm sorry. So, you're going to need about 9 things. I had to read this in my book. It's a physical science, 2nd edition. So, you're going to need some plastic tubes of water for the water. You're going to need water, duh. You're going to need a 9-volt battery. New one works best. You're going to need a glass, a clear one. You're going to need Epsom salt. And you're going to need a tablespoon, which I will grab in a minute. The eye protection, such as safety goggles or glasses, I don't miss those. Alright, so let's get started. First thing that we're going to have to do is fill the glass with water. Alright, you're going to need it about this full. So fill it up all the way. Next, well, we're going to need the tablespoon. And we're going to have to put in 3 tablespoons of salt into this cup. So 3 tablespoons of salt. It has to be Epsom salt, or otherwise this won't work. So let's open this up. Add 3 tablespoons of Epsom salts into the water. 3 tablespoons, not teaspoons. So let's do this. 1. There's 2. And then there's 3. Now this experiment is 4.1, so you may need to save the salt for the other experiments. And the next thing you do is you have to stir the salt and the water until they dissolve. Almost kind of looks like milk water, except really salty. Not as much protein. Alright. So that looks pretty dissolved, don't you think? 3 tablespoons. Jeez, that's huge. So, we're going to need the 9-volt battery. Did it really say tablespoons? Holy crap. Okay, so stick this. Now, you can't see this. So what I'm going to do is I'm going to adjust my cell phone, bring it up. I'm going to show you a close look. If you can see that there are bubbles appearing into. You see that? Very impressive. I'll show you just so you can see it just well enough. If you can see that just fine, then perfect. Now you're going to want to let that happen. Now, while we're doing that, let's continue on our experiment to see what we are doing. And that looks just right. See, as you can tell, it is clearing up. So, what we're going to need next is... So, got some difficulties here. We're going to have to let this battery sit for 10 minutes. So, while we're doing that, we're going to get all other stuff out. So, we have the plastic tubes. And this is going to have to go into the water. So let's take these apart, shall we? Alright. Now, as you can see why that's doing that, we're going to this is going to have to go for 10 minutes. Honestly, it's looking good. Let's perfect. So while we're doing that, get all the tape off of your tubes. If you don't have these, when they come in the module 4 bag, you can just like get these out a hobby store or something. But these came in the bag, so I was mostly expecting that. Later I'm going to upload another video. It's module 4.2. And we're going to have to keep everything, because all this is for module 4. There's more than that. There's like cooking oil and there's dish soap. But we're not going to need these for these experiments. But it'll tell you what you have to use and what you have to save. Like we have to use a 9-volt battery and the scissors from module 1. I got some scissors. Kitchen scissors will work too. And then the small nail in place of pen. So I think that's what we're going to have to use for this experiment. I don't know. Let's see that. No, we don't. Just 9-volt battery, 2 test tubes, juice glass, the salt, tablespoon, and then the 9-volt battery. And of course, water. So I think we got in about 3 minutes of this experiment here, or 2 minutes, about letting this sit into the water. So let's see what we're going to need next. We are going to need... Okay, so the reason that we must do this is that there is air trapped in the battery, and the air escapes in the form of the large bubbles. Now, if you watch the battery for a few minutes, like we did before, we saw some large bubbles coming from the water of the terminals or from the edges of the battery. Now these are air bubbles here. And those air bubbles, I think it might mess up the experiment. Oh, let's just hope that we don't, because I've never done this experiment before. So after 10 minutes, take your test tubes and fill them completely with the solution of the... Wait. Take your test tubes and fill them completely. I think we're going to need a bigger glass. Oh. Now, you don't want these to fall apart, so we're just going to take them together. I don't know why I took them apart in the first place, but that's okay. Just keep them together so they won't fall apart during the experiment. Now take the test tubes and fill them completely with the solution in the glass. Best way to do this is to fully immerse the test tubes, tilting them to let all the air out. In the end, there should be no air bubbles in the tubes. If you cannot fill the test tubes from the glass, make another mixture of water, Epsom salts in the bowl, and fill the test tubes from the bowl. Okay, so this is going to be a little different. We're going to need the salts, so let's get a different cup, I guess, because we're going to have to fill these test tubes with water, with the same solution of water that this battery has. So let's do that. And we're going to have to let out all the air bubbles. So let's just get a certain bowl, whatever. Alright, now, we're going to have to make sure that these stay full, and they have to be completely full. So, let's add those. Let's add the salt again. I'm doing this right. Okay, so it seems like we are out of the salt now, so we're going to have to let this dissolve for sure. Let's move this just so we know what we're doing. Now, this doesn't have to be completely dissolved. we have to take the two tubes. Now, let's see. We have to full. So yeah, there really was a point to having these taken apart. Okay. We're going to have to fill these with water. Now they have to be completely full. Make sure that there are no air bubbles in there. Otherwise, this would mess up the experiment for good. No air bubbles, guys. No air bubbles. There we go. Now, take the two tubes, and while keeping their open fully immersed in the solution, hold them upside down. The solution will not pour out as long as you keep the tops of the tubes submerged in the solution. Okay. So what we're going to do is that we're going to place these. Now, what we're going to do is that we are going to bring these over the battery. So, have to be really careful because you don't know if this is going to dump out. So, we're going to do this one tube at a time. So let's keep one in the water. Now, yes, I know it looks different, but that is the way how it's going to have to look. Keep it as still as possible. All right. Now check that out there. You see that? We got a little difference there. I'm going to bring this on just a bit. Now, it's just to put two knives in to make it practically level, but now, as you can see you see the difference between here? Look at that. If you're watching this carefully, you can see that this tube here, the water is going up and then it's coming back out. But the other one, it's going up. It's not coming out. And I think the reason why okay, now just be sure not to get any of this solution in your mouth. The chemical coming from the battery can be toxic. So, we gotta wash our hands. So, wash good. Alright. And as you can see, that's pretty different. From this side, the water is going up and out, but this side, the water's just going up. It's not going out. See, and this is exactly how it's supposed to look in the book. If you can see it, I'm using the second edition of the Physical Science. This is what you want it to look like. Just like that. Water's full for that side. This side, it's half full. You want it like that. Now, as you can take a look, the one that's clear is oxygen gas, and the other one is hydrogen gas. Now, the test tube is holding the water and trapping the hydrogen gas and oxygen gas as they are being produced. That's pretty cool. experimental air, huh? Now this is exactly what you wanted to do. It's cool, isn't it? I don't know if you can tell the difference of this, but the air bubble is... Wow. There are air bubbles actually going in there now. Now the hydrogen gas has formed. We formed hydrogen gas. We formed the differences between hydrogen gas and oxygen gas. It's pretty cool, right? Since all the hydrogen and oxygen gas comes from breaking down water, what can we conclude about the relative number of hydrogen atoms and oxygen atoms in a water molecule? Well, we can say that there must be more hydrogen atoms in a water molecule than oxygen atoms. In the end, then, this simple experiment gives us insight into the chemical composition of water. Now, since if our experiment worked perfectly, I mean, it might have, or it might have, it might have not. You have collected twice as much hydrogen as oxygen shown below. So we collected more hydrogen than oxygen gas. Pretty cool. Now, if this experiment did not work out for you, it's probably because of experimental error. So, this is the experiment I wanted to show you. 4.1, the chemical composition of water. Be sure to like and subscribe to this video. And I hope you all enjoy. More is coming soon.